Hi everyone, this is a review for trigonometry functions and actually the chapter 7 test that we took. So let's get started since we have so much to cover. So we're going to start off with finding the exact values of each of the functions. So you have arctangent of 1, which is asking you where's tangent 1 within the restricted domain that we have for tangent. Remember, tangent's restricted domain goes from quadrant 1 to quadrant 4. They want to know where tangent is 1. So it's positive on top, negative on the bottom. So the negative part, that's out. So we must be in the first quadrant. Tangent, opposite over adjacent, 1 over 1. Where we're at is a 45-degree reference angle. We want you to put your answers in radians. So you would say 45 degrees. If you could put your answer in degrees, we prefer you put it as pi over 4. For this problem here on the right, also cotangent has the same restrictive domain that tangent has, since it's a reciprocal function. But because it's a negative, the top, which is the positive, is out. And so we are now in the bottom fourth quadrant. Now where that came from, if you don't know right off the bat what negative root 3 over 3 is, ask yourself, where did that stem from? So think about 1 over root 3 and how you rationalize the denominator. Now, tangent being opposite over adjacent, cotangent is adjacent over opposite. So that means this would be a 1, and this would be a root 3 over here on the right. Because it's going down, it is negative. What root 3 is opposite of is a 60-degree reference angle. So think of this, you are here on this angle, you are going to be dropping down. And so that is going to be a negative 60 degrees or negative pi over 3. For this problem here, think of 2 over 1. Secant being the reciprocal of cosine, cosine having a restricted domain of first and second quadrant. And so what we're looking at is, because it's negative, the first quadrant's out. So we're thinking about an angle in this quadrant right here. And so with our reference, with the right triangle right here, secant is a reciprocal of cosine. Cosine is adjacent over hypotenuse. This makes this hypotenuse over adjacent, which makes this 2, the adjacent side 1. Because it's negative, you know the hypotenuse is always positive, so that must make this 1, which makes this root 3. Therefore, the angle opposite a root 3 is their 60 degrees. This right here is pi over 3, but that's not the angle. Remember, the angle starts at 0 and goes all the way across. So this has to be 2 pi over 3. For this problem right here, again, similarly like the cotangent on top, this one, think of where that stemmed from, and that came from 2 over the square root of 3 before we rationalize the denominator. It's also negative. Cosecant being the reciprocal of sine. Sine is opposite over hypotenuse. This would make this hypotenuse over opposite. And the restricted domain for sine is the first and fourth quadrant, just like tangent and cotangent. So what we're doing is here, we are a negative value, so the first quadrant's out because that's positive. So we're in the fourth quadrant, and therefore the hypotenuse is positive 2. Hypotenuse is always positive. So the opposite side must be the negative value for negative root 3. And so where are we at? Again, across from root 3 is a 60-degree reference. And try to imagine yourself here at 0, where you could only go up to 90 degrees or down to 90 degrees. So you're going down. You're not going all the way around. You're going down. This is a restricted domain, meaning you cannot pass. You shall not pass past that domain. So it's locked. You have to go down. So this would be negative pi over 3, and that would be your answer for that. For these problems here, they're composite. So you do have to find the inside first. Inside first, inside first. So you draw a little axis. And secant's reciprocal of cosine. Again, cosine's restricted domain is first and second quadrant. Because it's negative, first quadrant's out, we are in the second quadrant. Secant being the reciprocal of cosine, cosine adjacent over hypotenuse. Therefore, this must be hypotenuse over adjacent. My hypotenuse has to be positive. This must be 9. That means my adjacent side is 8. That's negative. In order to find that third side, though, I am going to use Pythagorean theorem, a squared plus b squared equals c squared. But if you have your hypotenuse, you're always going to take that value, square that, and subtract the other value that's squared. And it's always going to be positive. So you have 81 minus 64. And so 81 minus 64, I'm going to borrow that 7 here, 17. Is that 17? Therefore, this angle is the square root of 17 because it's a square, perfect square. What you have to do now is picture yourself, you're here, this is you, right there at that angle. And this is saying, where is secant negative 9 over 8? Here, right here, where you're at. And now this is saying, what is tangent where you are? We're here. What's tangent? Tangent is opposite over adjacent. So this is going to equal negative root 17 over 8. Okay. Again, inside, do the inside first, make a little angle or axis, and then secant, again, reciprocal of cosine. First and second quadrant, another negative value. I'm over here. Secant being hypotenuse over adjacent. So this is 8 over negative 5. So we have 64 minus 25. So that's going to be 6, 5, what is that, 39. So this is the square root of 39. So this is saying, where are you? And you should say, I'm right here, right there at the axis. And then therefore, check, we did this. This is saying, what is tangent of where I am? I'm here. What's tangent? Opposite over adjacent. So this is the square root of 39 over 5. Okay, and so that would be my answer. Leave it, it's done. For these problems here, I don't want an exact value. I want the general formula. That means I want every single value from now till forever. And so usually you're either going to write your answer as plus or minus 2 pi n or plus or minus pi n, depending on what quadrant you're in, okay? For this problem on the left, you have to realize what your objective is. And your objective is to solve for theta, to get theta by itself. Isolate the variable, which is theta. If you do not like theta and you're thinking theta is just doesn't make sense to me, I want to call this x. So I'm completely fine with that. A lot of people will say, hey, okay, call it x. Done. Add 3 to both sides, I get 12. So 12 is equal to 4 times cotangent squared of x. Divide by 4. I have cotangent squared of x is equal to 3. I'm going to square root both sides because ultimately, again, we got to solve for x. And x is underneath, it's protected by this root here. And so when we get that, we get cotangent of x is equal to plus or minus the square root of 3. Now, again, we're trying to solve for x. So we need to lose the cotangent. That's going to go on the opposite side. Every time you go across the equal sign, it changes. It's an inverse, etc. So we have x is equal to arc cotangent of root 3, but also x equals arc cotangent of negative 3, root 3. Those are two separate different answers, and you have to be accountable for both. So where's cotangent root 3? Think about, you have no restrictions. So even though we had a restricted domain with the previous problems, this part where it says find the general formula up at the top, all bets are off. There's no restrictions. I want every single answer there could possibly be. And so now I'm going to think of this as being over 1. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. So we know cotangent is not positive here. It's not positive here. It's got to be negative in this quadrant. So therefore, for this one, adjacent, which would be negative root 3, opposite is 1, this is 2, use Pythagorean theorem if you're not sure. And so where are we? That has a 1 across from it. So we're at 30-degree reference. So this is 30 degrees down here, which means it's pi over 6, meaning this little portion from here to here is pi over 6. What that means for you is that from here to here is 5 pi over 6, because this is pi. Pi minus 1/6 is 5/6. So for the negative value, in this case, this one value here is going to be 5 pi over 6. At the same time, cotangent is negative, also positive here, but negative in this quadrant, which is, again, going to be a reference angle of pi over 6. So this is going to be 1 plus 5/6. So 1 and 5/6 is 11/6. 11 pi over 6. Now, for this one right here, it's the same reference angle, but I'm in the positive realm. So where am I in the first quadrant? Pi over 6. Pi over 6. In the second quadrant, no, I already got that one, but also I'm positive in the third quadrant. 1 and 1/6. So 1 and 1/6 is 7/6. So this is also 7 pi over 6. So the way you're going to write your answer for this problem, okay, think about whether or not you want to say plus or minus 2 pi n or plus or minus pi n. So for this problem here, if I want to write my answer as, I'm actually running out of room, so I'm going to move this over to the next page, but if I want to write my answer as all 4 of these values, I could say pi over 6, I could say, and you would technically write it for each one. So you go plus or minus 2 pi n. You could say 5 pi over 6 plus or minus 2 pi n. You would say 7 pi over 6 plus or minus 2 pi n. And you would say 11 pi over 6 plus or minus 2 pi n. So that would get me, all of these values would get me all the values forever and ever. Okay, but, I mean, at the same time, think, do I actually have to write all 4 of those values, or could I just simply write pi over 6 plus or minus pi n? Meaning, if I'm here at pi over 6, and I were to add pi, I would end up being over here at 5 pi over 6. So there's no reason to put 5 pi over 6, because I would get that by just adding pi. The other one that I would use is this one right here, 5 pi over 6, or sorry, 5 pi over 6. The other one was what? 7 pi over 6, sorry. And so I could also write 5 pi over 6 plus or minus pi n. So think about that. That would get me here. So let's think about this one more time. Here I am at pi over 6. If I add pi, I'm down here at 7 pi over 6. And then if I add pi again, I'm up here at another pi. Likewise, if I'm here at 5 pi over 6 and I add pi n, now I'm here at 11 pi over 6. So there's not really any reason for me to put all 4 of these if I can condense my answer into 2 little parts and adding pi n. So this is how I would suggest you write your answer, but there is absolutely nothing wrong with saying this and finding all the values in every quadrant, okay? So I'm going to add a page because I didn't do this problem and I want to. So I'm going to just, that's going to go away. Let's add one more page. And so now I want to solve this one for all values. Again, different problem. Again, if you don't like this pi, or excuse me, this theta, you can make this into an x if that makes you happier. Subtract 1, I get 4 times tangent squared of x plus 1, I subtracted 1, that's gone, is equal to 4. I'm going to divide by 4. I get tangent squared of x equals 1. And you've got to get rid of the square. So I'm going to square root both sides, and when I do that, on the left, I get tangent of x. On the right, I get plus or minus 1. So now what's happened, because the square root of 1 is plus or minus 1. So now what happens is I've got x equals arctangent of 1, and I've got x equals arctangent of negative 1. So I've got 2 answers, but each of those answers, again, has 2 solutions. Where's tangent positive 1? Right here. Where am I? 45 degrees, pi over 4. I'm also here in the third quadrant at 1 and 1/4. But there's not really any reason. I absolutely can say that that's 5 pi over 4. But there's not really any reason to do that because I'm going to find the negative value. I'm going to add pi to both. I'm going to cover both. For this one, where is tangent? -1. Here. Tangent is -1 right here. Because see, opposite over adjacent, like that. Where am I? I'm at 3 pi over 4. So 3 pi over 4. So my answer for x, or theta, if you prefer theta, is going to be two values. It's going to be pi over 4 plus or minus pi n. And it's going to be 3 pi over 4 plus or minus pi n. So you've got those two answers right there are going to cover all the answers forever and ever because that's a general solution. Now, we can restrict the solution to just 2 pi. If that was the case when I was at 1, I would say pi over 4. Tangent is also positive 1 here at 5 pi over 4. So both of those values would be the answer. Similarly, if I wanted to find also where tangent was -1, it would be all the way over here in the fourth quadrant at 1 and 3/4. So 1 and 3/4, 7/4. So 7 pi over 4. So all four of these answers would be true and excellent to write my answer. But at the same time, if I didn't just write these two solutions, I could have written this like this. Pi over 4, 5 pi over 4, 3 pi over 4, and 7 pi over 4. All of those, x equals, all of these plus or minus 2 pi n. And that also would be a completely acceptable answer because you're including all four of the values plus or minus 2 pi n. So you have to ask yourself, what makes sense to you? Does this one make sense to you, or does this one make sense to you? And whichever one of those makes sense to you or you understand better, that's how you would write your answer. For this one, I'm restricting the interval. I only want values not forever, so you're not going to add 2 pi n. You're not going to add pi n. I only want the values from 0 to 2 pi, but do you see the parenthesis? Not including 2 pi. So we're going to solve for this theta, or x, however, and I think, I don't know, I think maybe I'm just going to change these to x's, because I feel like maybe some of you would benefit from having x's here instead of theta. I'm not sure. But what I do understand is that this is a squared value, and I need to set everything equal to 0, because it's quadratic. Whether you've got cosine or sine in there, it's still considered quadratic. So I'm going to set this equal to 0. I'm going to move everything over. I've got -3 cosine squared of x minus sine of x minus 1. Now, like all quadratics, if we were going to factor this, right, we would go cosine times cosine, cosine squared. But here's where the dilemma is. We have cosine and we have sine. And if you're going to solve a quadratic, you can't have x squareds and y's, right? You have to have all x squareds, or you have to have all y. You have to have all, not all x squareds, but you have to have all the same variable. And we don't have all the same variable. So before I can factor, I have to change one of these to cosine or one of these to sine. So in order to do that, I need to use one of my Pythagorean identities. And it's this one. Sine squared of x plus cosine squared of x equals 1. I'm going to replace this cosine squared with one of my Pythagorean properties. So I'm going to isolate the cosine squared. I've got cosine squared of x equals, and I'm going to move this sine over to the other side. So I've got 1 minus sine squared of x. This is what needs to be replaced into right here. So then I will have all sine. So we're going to go -3 times the quantity, 1 minus sine squared of x, okay? Minus sine of x minus 1 is equal to 0. So I'm going to distribute the 3. I get -3 plus distribute the 3. 3 sine squared of x minus sine of x minus 1 is equal to 0. And I know it's quadratic, so I'm just going to put the quadratic value first. Sine squared of x, did that. This one's next, minus sine of x. And lastly, I have negative 3 and negative 1, which is negative 4. This is what I need to factor, okay? So I need to factor this, just like that. Yes, you can use u substitution. I'm not going to. This is going to be 3 sine of x times sine of x. And that's going to make 3 sine squared. The signs here are plus and minus because that's going to give me a negative value. But keep in mind, I want a negative 4 because that's negative. So I'm going to go negative 4 times positive 1. And check your inside. So that's negative 4, positive 3 makes negative 1. So we have the right factor. We did that right. So the next thing we need to do is, after you confirm you've factored this correctly, is you're going to split this up. And you're going to set both sides equal to 0. I'm going to get sine of x plus 1 equals 0. Sine of x is equal to negative 1. X equals arc sine of negative 1. That's asking me, where is sine negative 1? On the left, I have 3 sine of x minus 4 is equal to 0. I have 3 sine of x equals 4. Sine of x is equal to 4 over 3. And x is equal to arc sine of 4 over 3. So again, keep in mind what you're trying to find. This is asking me, where is sine 4 over 3? And so I'm going to draw a little sine. I'm going to draw it up here. I'll do it up here. I'm going to draw my little sine graph. Remember, a sine wave, okay, sine starts at 0, goes up, goes down, ends at 0. Your job is to know that sine goes from 1 to negative 1, negative 1 to 1, low to high, range negative 1 to high 1. They want to know, where is sine 1 and 1/3? Well, that's up here. Where am I going to have any values up here? I'm not. There's no value here. That's no solution. There's no value there. For this problem here, and kids, remember, your sine values have to be between 1 and negative 1. If they're not in this parameter, in this range here, then they can't be an answer, okay? The other one is asking me, where is sine negative 1? Well, I'm looking at my sine wave. Sine is negative 1 right here. Well, where am I? This is 2 pi. This is pi. So this must be 1.5 pi, which is 3 pi over 2. So my interval, which is 0 to 2 pi, this is the only answer where sine has a value at negative 1. That's it. Okay, so that's my answer. Done. We're going to do another one of these. Same thing again. This is a quadratic. I'm going to move this over to the other side because if something is quadratic, you do always want to set it equal to 0. So I have negative 4 sine squared of, we're going to use x, minus cosine of x. Let me move this over a little bit. Minus 1 equals 0. And again, I want to factor, but I can't factor if my variables are different letters. And I don't just mean x, I mean sine is different than cosine, right? Because if you were trying to factor, I mean, think about it. If you were trying to factor this, right, you would probably say, okay, negative 2 sine, or you'd say 4 sine, right? Sine of x times sine of x, right? So if I had sine here of x and sine of x here, and then I had a value here and here, when you think about this, I get sine and I get sine. How is that ever going to be cosine? It's not. And so therefore, you have to replace either the sine squared with a cosine or a cosine with sine. And because we don't have any identities that are not squared values, then we have to replace this, all right? And we're going to go back to the same one, which is cosine squared plus sine squared is equal to 1. And I want to replace sine squared. So that's the one I want to isolate right here. So that means that sine squared of x equals 1 minus cosine squared of x. And in this case, this is what I'm going to replace it with. So I'm going to go negative 4 times 1 minus cosine squared of x. Change it. Minus cosine of x minus 1 equals 0. I'm going to distribute this times this times this. I get negative 4 plus 4 cosine squared of x minus cosine of x minus 1 is 0. Now just combine like terms. I get 4 cosine squared of x. Then I'm going to do the cosine next. And then negative 4 and negative 1 is negative 5 equals 0. And so now we want to factor. Okay? And I'm going to stick with 4. And I'm not going to make it 2 times 2. I would try 2 times 2 if I didn't think that the 4 would work. The reason is I'm trying to get 5. And if I split it up into 2 times 2, I'm going to get like a 10. And I don't want that. So I want 4 times cosine of x, and times cosine of x is cosine squared. Done. To get 5, it's either going to be 1 times 5 or 5 times 1. And just think about it. Use your noggin here. 4 times 5 is 20. I'm trying to get negative 1. It's not going to happen if the 5 is here. Okay, so it doesn't go there. So we want to put the 5 here, and we want to put 1 here. And so now it's just a matter of trying these out. If I go plus and minus, this is 5. This is minus 4. 5 minus 4 is 1. I want negative 1. So therefore, I need to change my signs. All right, so instead of plus and minus, I'm going to use minus and plus. So this is a minus, and this is a plus. And when I check, again, negative 5, add 4 is negative 1. Check. So now all we have to do is split this up. We have cosine of x plus 1 equals 0. We have cosine of x equals negative 1. X equals arc cosine of negative 1. This one, 4 times cosine of x minus 5 is equal to 0. 4 cosine x equals 5. Cosine of x equals 5 over 4. And they want to know, when is cosine going to be, that's our cosine. When is cosine going to be 5/4? And when is cosine going to be negative 1? Again, I'm going to draw my graph. And this one's not sine, but it's cosine. Cosine starts high, goes down, ends high. The range is 1 to negative 1. And so this is saying, where is cosine? Every time you see that arc, it's asking you for the angle. Where are you? What angle are you at where cosine is negative 1? Well, down here. Where am I? Where am I? Right here. Where am I? This is 2 pi. This is pi. Where is cosine negative 1? Pi. That's it. Just one place between, and because remember, it asked me for 0 to 2 pi. So there's only one place that cosine is negative 1. But think about it, if this had been a general solution, I would have said pi, and then I would have said add another 2 pi, plus or minus 2 pi, because that's what it would be. It wouldn't be add pi, because that would put me at 2 pi. It would be add another 2 pi, right? Okay. This one is saying, where is cosine 1 1/4? Up here again. Well, it's not going to happen. There's no value here. It's only at pi that's going to satisfy this equation. These two problems here are just simplifying. The goal here was to try to factor out something common. What that means is this. If I had 2x minus 2xy, what's common between these? Well, 2x. So if I factored out 2x, factor means divide. I divide out a 2x here, I have a 1. I divide out a 2x here, I have minus y. That's it. Okay? Simplify for sure. But that's pretty much the concept. All right? So think about that. Let's do this right here. I see 2 secant, 2 secant. I'm going to factor out a 2 secant of theta. Well, what's left if I divide out a 2 secant of theta, 2 secant of theta? What's left? In the first part, there's 1. On the second part, these would cancel, and I'm left with sine squared of theta. Well, okay, what's 1 minus sine squared? We just used that formula before. Sine squared plus cosine squared equals 1. Cosine squared is equal to 1 minus sine squared. So therefore, this is cosine squared. So I've got 2 secant squared times this, which is cosine squared of theta. Try to keep the same variable. I need to change this because cosine squared, fine, secant's 1 over cosine. So I've got 2 times 1 over cosine times cosine squared. Now I'm going to write it like this for those of you who don't see that there's actually 2 cosines, meaning one of these will cancel with one of these. You get 1. And what you have left is multiply straight across is 2 times cosine of theta, and you're done. Leave it alone. For this one, I noticed that there is a 2 secant, cosecant, similar. We're going to factor that out. 2 cosecant of theta. Take that out. Divide out. Divide 2 cosecant of theta, 2 cosecant of theta. That cancels. I get 1. Minus. This cancels. I'm left with cosine squared. Well, 1 minus cosine squared is sine squared. And I didn't write that right. Sorry about that. CSC. CSC. So this is going to be 2 times this, which is sine, 1 over sine, times this, which I'm going to replace with sine squared of theta, which I'm actually even going to write like this, sine of theta times sine of theta. Okay, one of these signs are going to cancel, and I'm left with 2 times sine of theta, and I'm done. Okay. This one, I just wanted you to, what I want you to do is simplify just one side. And because it's a proof, all right, it's a proof. Work the left side or work the right side, but really, really, really try to work one side only. And by working one side, what I'm asking you to do is to try to make this side look like that side. This is always, you always try to do the hardest part, and I think this one is a little bit trickier because you're going to multiply by the conjugate, which is 1 plus sine of y over 1 plus sine of y. And the reason for that is when I actually multiply by the conjugate, the denominator is going to become something that I can deal with. It's always going to be like that. It becomes a difference of 2 squares, which is what this is, right? I'm not going to I'm not going to, distribute right now. Although I could. I don't want, hold on. So I'm just going to rewrite it. Cosine of y times 1 plus sine of y. And part of the reason why I don't want to touch this is because it's right here. I want to try to lose everything near there so that it'll be the same, okay? Now on the denominator, I am going to just FOIL. So this becomes 1 minus sine plus those cancel, and then you get minus sine squared. But 1 minus sine squared is actually cosine squared. So I'm going to replace this on my next step. So right now I've got cosine of y times 1 plus sine of y. And this is all over cosine squared of y. Now, I recognize that, and I absolutely can write this twice. If that makes you happy, do that, right? But one of these cosines will cancel with one of these, which is one of these, which means that I have 1 plus sine of y on the top, because that became 1. On the denominator, I just have 1 cosine left. And if I look to see actually what I'm trying to prove, we did it. So you're going to draw this little arrow straight down. You're going to go 1 plus sine of y over cosine of y. You're going to little box that up. And you're done. Okay? Our job here to find the exact value of 165. sine of 105, and a sine of 255. So these are just angle sum and differences, right? I want to try to make 165. I'm going to go with, I'm thinking, what am I going to do? 120 plus, I think 45, right? 45, 55, 65. Yeah, that works. So we're going to go cosine of 120 plus 45. Okay? And what this is now you're going to expand that, right? Cosine goes cosine, cosine. So we're going to go cosine of 120, cosine of 45. It's opposite signs. Plus, this is minus. Then it goes sine of 120 and then sine of 45. So I'm going to draw a little angle here. So I remind myself cosine of 120 is in this quadrant with a 60-degree reference, which means that 60 degrees sine is going to be root 3 over 2 positive. So that's this one. So this one here is going to be positive root 3 over 2. But in the first quadrant, cosine is going to be negative 1/2. And if you need to see that, and I know you can use your tricks with that, your little unit circle, but if you forgot, let me show you. This is 120, which makes that 60. That's root 3. This is 2, and this is negative 1. Sine is root 3 over 2, opposite over hypotenuse. I put that one in right here. And this one is cosine, which is 1/2, negative 1/2, adjacent over hypotenuse, and that one's this one. Now, cosine of 45 is root 2 over 2. Sine of 45 is root 2 over 2. Also, both of those first quadrant, you got that, minus. So my final answer here, and you just multiply numerators with denominators. Okay, so I've got negative root 2 over 4 minus root 6 over 4. And some people like to combine those, which is completely fine. And you would get negative root 2 minus root 6 all over 4. And that would be your answer. Done. Okay, sine of 105. I'm going to use sine of, let's see, 60? Yeah, plus 45. And so that's going to be equal to sine of 60, cosine of 45. Sine is the same. Cosine is different, right? I had to change the sign, but sine is the same. And then it would be sine of 45 and then cosine of 60. So sine of 60 is root 3 over 2. So root 3 over 2. Cosine root 45 is root 2 over 2. Plus sine of 45, root 2 over 2. Cosine of 60. 60 is here, right? Root 3, 2, 1. Cosine is adjacent over hypotenuse, so that's 1/2. So what I have is root 6 plus root 2, yeah, over 4. And then you're done. This one, let's see, 255. I don't know. What is that going to add up to be? What do we want to try? I feel like it's going to be like 235. Let's check. Let's see, 255 minus, I don't know, 120. 135, that'll work. So meaning I'm going to use sine of 135 degrees plus 120. So that one is definitely maybe a little trickier, I'm not sure, but it's still doable. Thinking of this, I'm going to draw two little axes. I've got 135 is here, right? With a 45-degree reference. So 45, remember, goes 1, 1, square root of 2. 120, also second quadrant, but that's a 60-degree reference. And we did that one up here with cosine. Still, root 3 here, 2 here, negative 1 here. Negative 1, 1, square root of 2. So let's expand that. We get sine of 135, cosine of 120, sine is the same, plus sine of 120 and cosine of 135. Sine of 135, wait, this is 135. Sine is opposite over hypotenuse, so that's root 3 over 2, positive. Cosine, oops, that's wrong. Hold on, I messed up. Sine of 135, this is 120. Okay, I labeled this wrong. 120, and this is 135. So sine of 135 is the same thing as saying sine of 45 degrees, which is root 2 over 2. Cosine of 120 is adjacent over hypotenuse, so that's negative 1/2. Plus sine of 120, again here, which is root 3 over 2. And cosine of 135 is adjacent over hypotenuse, which is, again, root 2 over 2, but negative root 2 over 2. And so this is going to be negative root 2 minus root 6 all over 4. Okay, good. So for this one, this is another identity, sine of 2x. So sine of 2x is equal to 2 sine x cosine of x. And for this problem, we're going to draw the graph. We've got cotangent, tangents opposite over adjacent, cotangent, adjacent over opposite. And so I got to know what quadrant I'm in, though, because that's a little tricky. Cotangent is negative. Where is cotangent negative? Not here, not here. Also, you have to satisfy this requirement, that sine is negative. So of the remaining two sides, the only place that sine is negative is here. So this is also out. So when you draw your triangle, it's got to go all the way over here and bring that back up, okay? Now this is saying cotangent is adjacent over opposite, 5 over opposite, negative 3. I think the biggest mistake, or one of the largest mistakes that I saw on this problem, was that kids thought that this was a 3, 4, 5 triangle, which it is not. Because for this to be a 3, 4, 5 triangle, the 5 would have to be the hypotenuse, and it's not. So therefore, I do need to use Pythagorean theorem. 25 plus 9, a squared plus b squared. 25 plus 9, what is that, 34? So this is the square root of 34, okay? So now that you're here, this is where you're at, that's you with hair, okay? Sine of 2x, find sine of 2x. We're going to go 2 times sine of x, opposite, over hypotenuse. So we've got negative 3 over the square root of 34 times cosine, which is adjacent over hypotenuse. So that's 5 over the square root of 34. And so what we have here is you've got to multiply straight across. And so this is going to be sine of 2x is equal to 2 times 3 times 5. So 6 times 5, that's negative 30 over 34. Now, because root 34 times root 34 is 34. I know some kids get confused with that. Think of it like this. The square root of 2 times the square root of 2, you think, oh, that's the square root of 4, which is 2, whatever's inside. Or the square root of 3 times the square root of 3, well, that's the square root of 9, which is 3. So basically, if I said the square root of 50 times the square root of 50, I'm going to get 50. All right. Also, you can reduce this. If I divided this by 2, I get negative 15 over 17. All right. I took both answers, but that's it. For this one, I'm asking you for cosine of 2x. Again, your biggest issue is to draw the graph in the correct quadrant. Okay. Tangent, negative. Do you see the negative sign here? Where is tangent negative in these quadrants? Not here, not here. So of these two remaining quadrants, where is cosine less than 0? Meaning, where is it negative? Not here. So we must be in this second quadrant. Draw your triangle. Negative 5/4, opposite over adjacent. So 5 over negative 4. Again, not a 3, 4, 5 triangle. We've got 25 plus 16, which is 2, 3, 41. So this is the square root of 41. Okay. Cosine of 2x is equal to, now there's 3 different formulas to use, right? 1 minus 2 sine squared of x, 2 cosine squared of x minus 1, or, this is my favorite, cosine squared of x minus sine squared of x. I like this one. I'm going to use this one. Cosine squared is adjacent over hypotenuse. So we're going to go negative 4 over the square root of 41, and this is quantity squared because of that 2 right there. Minus sine squared, opposite over hypotenuse. So 5 over the square root of 41 squared. So what this makes is 16 over 41 minus 25 over 41. What is that? 9? Negative 9 over 41. Answer. Check. And lastly, we have a problem like this. And yes, this was challenging, definitely. But I think what you could do is, this is the easiest way to do this that I can think of, is to just separate these as to here's angle A, here's angle B, and draw the two angles. I mean, that's what I would do. That's what I did. So we have two angles. And so what's happening here is cosine of A, that's A. Where is it? We have restricted domains. Where is cosine? Negative 5 over 13. Cosine is negative in the second quadrant. That's where I'm at, right there. Cosine is adjacent over hypotenuse. Also note to self, this is a Pythagorean triple, 5, 12, 13. Where's tangent? 4 over 3. Tangent's restricted domain is here to here, okay? Which means that you have, this is positive, so this is out. So we are in the first quadrant. Tangent is opposite over adjacent. This is a 3, 4, 5 triangle. Because in order for it to be a 3, 4, 5, the hypotenuse has to be 5. Or the hypotenuse has to be the biggest side, right? All right, we are expanding sine. Just like the ones we just did earlier, this is sine of A minus B. And so think of what you're writing. You're going sine of A, cosine of B, minus, because these are the same, sine of B, cosine of A. All right, and some people like to flip these, and that's fine. I don't. Just leave it alone. Sine of A. Where's A? This is A, okay? Put yourself here. This is sine. Sine is opposite over hypotenuse, 12 over 13. Excuse me. Cosine of B. Here we are down here at B. This is B. Cosine adjacent over hypotenuse times 3 over 5 minus sine of B. Well, I'm back down here. Sine B. Sine opposite over hypotenuse, so 4 over 5. Cosine of A. You're back up here. Cosine adjacent over hypotenuse, so negative 5 over 13. Multiply. 12 times 3, 36 over, what is that, 65? Minus negative 4 times negative 5, that's a plus, right? Hold on, let me double check. Sine of B, sine opposite over hypotenuse, that's positive. Cosine of A, adjacent, yep, that's positive. And so what is that, 20 over 65, so what is that, 56 over 65? Cool. What do they call that? That's something. They call that something where they flip the numbers. Is that a... I forgot what that's called. Anyway. Okay. Let's do one more of those. All right? I know. Your favorite. I get it. This is the last one. We can make your two angles again. Okay? Where is tangent? Negative 3/4. Remember, first, fourth quadrant. Down here. There I am. Tangents, opposite over adjacent. So we've got 3 over 4. This has to be negative. And this is a 3, 4, 5. And this is, we're going to call this A, because this is A. Here's B. There's B. Sine is opposite over hypotenuse. So this is my angle B here. Sine, first or fourth quadrant, it's positive. So I'm going to put it here. I'm not talking about, when I say it's positive, I'm not talking about this angle. Ignore this, minus sign. That has nothing to do with anything until we actually write this out, okay? What I'm talking about sine being positive is this. Value is positive. So that's opposite over the hypotenuse, and that's a 5, 12, 13. All right, cosine goes cosine of A minus B. So you're going to write it out. You're going to go cosine of A, cosine of B, plus sine of A, sine of B. So cosine of A, here we are. This is you, cosine, adjacent over hypotenuse, times cosine of B, down here, cosine adjacent over hypotenuse. Okay, plus sine of A, sine opposite over hypotenuse, negative 3 over 5 hypotenuse. Yeah, I just did that. Sorry. Sine of B, opposite over hypotenuse, 12 over 13. So we've got 20 over 65 minus 36 over 65 makes negative 16 over 65. There we go. Good luck. Good luck on your retake. Thursday, Friday of next week. All right? I hope this helped you guys. All right.